Today, we are going to study about oxidation number. It is also known as oxidation state. Here, I will be using abbreviation O.N. That means oxidation number. Oxidation number is a number given to each atom or ion in a compound that shows us its degree of oxidation. Oxidation number can be positive, negative, or zero. Students, remember it is important to note that an oxidation number refers to a single atom in a compound. Further, we can also say the oxidation number is basically the count of electrons that atoms in a molecule can share, lose or gain while forming chemical bonds with other atoms of a different element. Now we move down to some of the rules for assigning oxidation number. It is very important that we remember these rules, and as we keep on doing or calculating the oxidation number, the rules will stay with you and you'll automatically remember it. Rule number one, the oxidation number of a free element is always zero. Rule number two, the oxidation number of a group 1A element in a compound is plus 1. Rule number three, the oxidation number of a group 2A element in a compound is plus 2. Number 4, the oxidation number of group 7A element, those are the halogens, in a compound is minus 1, except when the element is combined with one having a higher electronegativity. Remember this. Number 5, the sum of the oxidation number of all the atoms in a neutral compound will always be 0. Number 6, the sum of the oxidation number in a polyatomic ion is equal to the charge of the atom. Number 7, the oxidation number of a monoatomic ion equals the charge of the ion. Number 8, hydrogen is plus 1, except in metal hydride such as sodium hydride where it is minus 1. Number 9, oxygen is minus 2, except in peroxide where it is minus 1 and in F2O where it is plus 2. Number 10, in either a compound or an ion, the more electronegative element is given the negative oxidation number. So these are the 10 rules that are assigned to find out the oxidation number. Now let us do some examples to understand oxidation number. Now the first example is, what is the oxidation number of hydrogen in water? Now the first thing that we do is let's assign oxygen oxidation number minus 2. If you look at the rule 9, you'll see oxygen has been assigned minus 2 oxidation number. Here we have to find out the oxidation number of hydrogen. So we can put it as X. Now let's calculate it and solve it. So 2x, why 2? Because there are 2 hydrogen, x for unknown oxidation number, plus we can put minus 2 in the bracket, equals to 0. Overall, a compound will have a 0 charge over it, so overall 0. So water has no charge over it, therefore we will always write 0 over there. Finally, x equals to plus 1. So hydrogen has an oxidation number of plus 1. So this is the oxidation number of hydrogen. To 1, that is plus 1. Example number 2. What is the oxidation number of phosphorus in phosphorus iodide? Now again over here, if you look at iodine, if we go to rule number 4, you will see iodine, we all know, is an halogen. If you look at rule number 4, what is assigned to it, you will see iodine has an oxidation number of -1. We have to find out the oxidation number of phosphorus. So we can make it as X. So let's solve it. 3 minus 1. Why 3? Because there are 3 atoms of iodine, minus 1 because it's oxidation number, equals to 0. Here overall charge is 0. So oxidation number of phosphorus equals to plus 3 in phosphorus iodide. Let's go down to the next example. Example number 3. What is the oxidation number of carbon in hydrogen carbonate or H2CO3? Now, this example of the compound, we see that there are 3 elements over there. Hydrogen is there, carbon is there, oxygen is there. So, what we can do is we can separate the carbonate and hydrogen. So we can write it as 2 2H plus. This is for the hydrogen, and carbonate we all know it has a charge of 2 minus. So hydrogen, again, if we look at the rule 8, we know hydrogen equals to plus 1, and then oxygen, according to the rule, we'll see oxygen equals to minus 2. And what are we finding? We are going to find out carbon. So we can put it as X. So let's solve it. Let's put X in the bracket, plus 3 for oxygen, and we all know oxygen has an oxidation number of minus 2. Let's enclose it in a bracket, equals to the final charge over carbonate, we all are aware of it, is minus 2. So X equals to plus 4. So therefore oxidation number of carbon here is plus 4. Now let's go down to the fourth example. Here we have what is the oxidation number of manganate in potassium permanganate. So let's see again over here, K plus, we can put it into two parts, K positive and MnO4. MnO4 has an overall charge of negative. Now K, we already know K equals to plus 1. If you want to go back to the rule 2, you'll see K equals to plus 1, group 1 alkali metals. And what we have to find out, manganese. Manganese, we can put it as X. Oxygen, again, according to the rule 9, if you go back, it is minus 2. Now let's calculate it. X plus 4. Why 4? Oxygen is 4. What is the oxidation number of oxygen? Minus 2. Close it into a bracket, equals to minus 1. Why minus 1? Because the overall charge of manganate is minus 1. So X equals to plus 7. So finally, therefore, the oxidation number of manganese equals to plus 7. So I hope you have understood it. I will come up with more examples and some more difficult examples after this.